A recurring decimal is one which a number is repeated, or a pattern of numbers is repeated after the decimal point. So something like 0.7777, and it keeps on going forever, is a recurring decimal. But so is the likes of 0.373737. If that keeps on going as 37 all the time, we call that a recurring decimal. What we need to be able to do is to change between fractions and recurring decimals, and also then back again from recurring decimals back to fractions. Let's just look at this 4/9. If we think this is as 4 divided by 9, and we're going to do this as a long division, say it's 4 point, let's go 0, 0, 0 to start with. Now, 9 doesn't go into 4, so we put 0 and go into decimal places and carry the 4. So how many times does 9 go into 40? Well, it goes in 4, remainder 4. So 4 up there and remainder 4. And now again we say how many times does 9 go into this 40? Well, it goes in 4 times with a remainder of 4. And 9, how many times does it go into 40? Well, it goes in 4 times with a remainder of 4. And as you see, this just keeps on going, keeps on going. So what we could say is that 4/9 is equal to 0.4444, and we would just keep on those 4s going. But the way that we write that mathematically sometimes is you see it as 0.4, and we put a little dot over the 4. And that little dot just signifies that the 4 is recurring. The 4 happens time and time again. So it goes 4, 4, 4, 4, 4. So we also need to know then how to turn recurring decimals into fractions, and to write them as fractions, or to write them as a rational number. And the method is very, very similar every time. The first thing is we write, say, x equal to our recurring decimal. I'm just going to write it out, 8, 8, 8, 8. Dot, 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 dot. And we know it's the 8 is repeated because the dot is over the 8. Well, what I want to do then is multiply it by a power of 10. And this time I'm going to multiply by 10x. Because when we do that, we get 8.888. And this also becomes 8 because after here, these are all 8s the whole way to infinity. So when we multiply by 10, those 8s just move up a decimal place. So we get 8.88. And now what we're going to do is we're going to take those two equations that we have and subtract them. So I'm going to start 10x, take away x is 9x. And likewise, 8.88888, take away 0.88888. Well, this is a cool thing in that all the 0.88888s cancel out, and we're left with 8 take away 0, which is 8. And now if 9x equals 8, x is equal to 8 divided by 9, 8/9. And so we've written 0.8 recurring as a fraction. Something similar can be done with this one, 0.14 recurring. And you'll see here that there are 2 dots over the 1 and over the 4. And that's saying that they are both repeated. So my value x here is 0.141414. Now this time, when I multiply by a power of 10, I want to multiply by 100 this time. Because if I multiply by just 10, then what I get is 1.414141. And when I subtract this line away from this line, it's not going to take away the decimals. Look, the 1.4 will not cancel with the 4.1. So we're going to get rid of that. And instead of multiplying by 10, this time we're going to multiply by 100. Because when we do that, every number moves 2 decimal places, or 2 places to the left. So it becomes 14.141414. Now again, we're going to subtract the top equation from the bottom one. And when we do that, 100x minus x is 99x. And again, when we subtract 0.141414 from 14.141414, all the recurring parts cancel out, and we're just left with 14 take away 0, which is 14. And so if 99x is 14, x is 14 over 99. We've written as a fraction or as a rational number. It's the 1/4. In this example, we still have two dots, but you'll notice there's a gap between them. And this means that the numbers between those two dots are all repeated. So the first dot's over 7, and the last dot's over the 3. So all the numbers between 7 and 3 are repeated. So it's 0. Our value of x is 0.723,723,723, and that keeps on going. Now again, to make sure that whenever we subtract the two equations, that the surd or the repeated recurring decimal part disappears, I need to move that 7, 1, 2, 3 places left. I need to move everything 3 places left. And we do that by multiplying by 1000. When we do that, we get 723.723,723,723, and that would continue forever, the 723s. So like the last time, we're just going to subtract the two equations. 100x minus x is 999x, and this time 723 take away 0, because the recurring parts cancel out, so 723 take away 0 is just 723. And so if 999x is 723, x is 723 divided by 999. And we should, if possible, simplify any fractions. And I can see that the top line and the bottom line are both divisible by 3. So it's good form just to change that as 241 over 333. In this last example then, the only difference is that we have a number at the front 2 and then 0.17, and it's the 17 that's recurring. But we can go about this in exactly the same way. Say x is 2 point, and it's 17 is recurring, so it's 1717, and that keeps going. So again, to make the 17 stay as that pattern, we're going to multiply not by 10, but by 100 this time. Everything's moving 2 places. So that becomes 217.171717. Again, let's subtract. And the bottom equation subtract the top equation is 99x. Just be a little bit careful here. Again, the recurring parts disappear because 171717 take away 171717 just is 0. But this time we have 217 take away 2. So overall, that's 215. And so x is, as a top-heavy or an improper fraction, 215 over 99. We've written it as a fraction or as a rational number.